Okay, today we're going to go over a Unit 3, Lesson 8 notes. This is talking about end behavior and odd and even functions. So with these, you're going to go ahead and go on to Desmos and graph them and then tell us about all of it. So this one is a linear because the x is to the first power. Anything to the first power is a linear. We graph it, crosses the y-axis at 3, and the slope is up 1 to the right 1, and it's just a straight line. This one, we're going to find out it is an odd function. We'll go over a little bit of odds and evens a little bit later, but just let's see what you know. And as x goes towards infinity, so as the x values go towards negative infinity, going this direction, what is the graph doing? And we can notice our graph is going down to the negative side. So we're going to go negative infinity. The y value, these are the y values. Okay. And as x is going towards infinity, as our graph goes up towards all the x's go towards infinity, our y's are also going to go towards infinity. Here, this one's called a quartic. Quartic. Quartic means 4, and it is going to, and when you graph it, it crosses at the 2 and negative 2. And it's sort of like a quadratic, but it's a lot wider at the base. Not very sharp like we did before. It's going to be very broad. This one I'm going to tell you is an even. And as the x's go towards negative infinity, so as we're going this direction, we can follow our graph. Our graph is actually going to go more to the positive infinity side, positive y values. And as we go towards the positive x's, our graph is going up to the positive y values. Okay, this one is a cubic. Cube means 3. So this is a cubic. It is an odd one. And as we graph, it is going to cross at about the 5 up here. And this one, hopefully you guys remember, we go up, over, and go up. And as it's going towards the negative on the x values, the y is also going to be going down. Our graph goes down. And on the right side, as we go to the positive x sides, our y goes to positive infinity side. Okay. All right, so with this one, it is a cubic. And it is odd. Okay. And again, it's going to cross at the on the y-axis at 5, but in sort of flipped. And with this one, as x goes towards the negative infinity side, our graph is actually going up to the positive infinity. And as we go towards positive infinity, our graph is going down. So it's going down over here. And here, this one is a logarithmic type of graph. It is neither not odd or even. And it crosses minus 1. This one. And as it goes towards the negative x's, it doesn't even go to the negative x's. So we call this one undefined. It doesn't even cross the y-axis. This one does go towards positive infinity as the x's go towards it. Okay. So some of the functions that are polynomials may be categorized as even or odd functions. When mathematicians say that it is an even function, they mean something very specific. So looking over these two graphs right here, the left one is an even. This one's not an even. Okay, so we're just looking at it and see what do you notice. We can see that the first one is a quadratic. The second one is an exponential. We have the one on the left. We can talk about in behavior like we did before. As on the left one, as x goes towards negative infinity, it goes positive. And as x goes towards positive infinity, it goes positive. On the one that's not an even, we can see as x goes towards negative infinity, the x's are a little bit undefined. They are going closer and closer to 0, so it doesn't really work. But as x goes up, it goes towards infinity. Okay. We can also make sure you write at least one comment of what you find in here. Same thing with this one. We can see this one. It's going up, going down. Sort of looks like a quadratic, but we know it is a quartic. The non-even, we can see as x goes towards negative infinity, it does increase, but then it does decrease, so it does both. Same thing was as x goes towards positive infinity, we do go down and then go up, so we can't really say the end behavior of this one. So maybe write one thing you noticed right here. Okay, and then here, an even function. This one's very specific. See, if we put in x is 2, we get a positive 5. If we put in negative 2 for x, we get the same answer. Okay, but if we do the same thing with one that's not even, we get two different answers. We get two different answers if we put in the positive and negative. Okay, so add in one difference here. Okay, the official definition for an even function is if and only if you plug in a number. If you plug in an x value, you should get the same y value as if you plugged in a negative x value. It's always going to do it. We will also know that as x, if you look back at our previous ones, all the ones that were even, they're both going in the same direction. They're both going up. That one's an odd. This one's not. Here, they're both end functions are the same. Okay, here their end functions are the same. So we're going to have same end functions. Okay, they're going to have the same end functions. Okay, now here we go. We have here's an odd. We can see the end function for the first one. It's going towards the positive. This one's going towards the negative. But this one is also the same thing. It's going towards the positive, going towards the negative. But we can see it's maybe a little bit lower from the origin. It's not going through the origin like this one is. So put in one difference here. Oops, excuse me. Then if we look at the next one, we have the same thing. This one is a little bit different. We have some asymptotes here. Okay, but we can see some different things here. It's not going through the origin like the previous, but it could be the same thing. Here, as we're going towards the negative side, we're going negative, going positive, we're going positive. But again, it is going down a little bit, more of a straight line. Okay. If we look at this one, here's where we get it. So if we put in a positive 2, a positive x value, we get a positive y. If we put in a negative x, we're going to get a negative y here. Okay. If we did the same thing, this is why this one is not an odd function. If we put in x equals 2, we get a positive 3. Negative 2, we get a positive 5. Put in a difference. Same thing for the previous one. Circle it. Okay. So here we can say that if we plugged in a positive x, we should get the same thing as with it being negative. Now, odd functions. Okay. Odd functions are going to have opposite end behavior. Okay. So opposite end behavior. It is also a 180-degree rotation around the origin. And if we look at this one up here, this one, if we rotate it, it will become this one, 180 degrees. If we rotate this one, it will come back to the same thing. So we do have it, that one. And since it is a 180-degree rotation, it can't be shifted up, down, left, or right. It can't shift that too much from it. Okay? And that's what we're going to get for odds or evens.